Hello, I am Meghna Pari and today we are here to start the lecture series of Mathematics 1. Our chapter is indeterminate form and topic is minus infinity by infinity and 0 to infinity formations. Okay, what is the working rule of the evaluate limit of the infinity by infinity? If limit f of x equal to infinite and limit x tends to g of x equal to infinity, then L limit equal to limit x tends to a f of x upon g of x. We say that 1 by g of x, 1 by f of x, it is 0 by 0 formation. So by applying L'Hopital's rule, we can calculate the value of limit. Example, evaluate limit x tends to pi by 2 log x minus pi by 2 upon 10x. Solution. Let L equal to limit x tends to pi by 2 log x minus pi by 2 upon 10x is infinity by infinity form, because if we put here pi by 2 minus pi by 2, there is a log 0 and 10 0 is infinity by infinity. Applying L'Hopital's rule, we are differentiate numerator and denominator. So what is the differentiation of log x minus pi by 2? It is 1 upon x minus pi by 2 and sec square x is differentiation of 10x. Now again we are differentiate this cos square x upon x minus pi by 2. It is 0 by 0 formation. So again we are applying L'Hopital's rule. 2 cos x minus sin x by 1. It is 0. We are taking second example. Prove that limit x tends to infinite 1 square plus 2 square plus 3 square up to x square upon x cube equal to 1 by 3. Now LHS 1 square plus 2 square plus 3 square up to x square, applying limit x tends to infinite upon x cube. We are taking formation as x plus 1 to x plus 1 upon 6x cube, because this is the x raised to square series. Now it is x plus 1, 1 plus x, we are taking x common 2x, 2 plus 1 by x upon 6x cube. This if we are taking infinity by infinity formation, so 1 plus 1 by x, 2 plus 1 by x upon 6, we get 1 by 3 as a RHS. Prove that a limit x tends to infinite, x raised to m, e raised to x equal to 0, where m greater than 0. Solution. We are taking LHS x raised to m upon e raised to x, applying x raised to infinite, we getting infinity by infinity formation. So we are take differentiation mx raised to m minus 1 upon e raised to x. Apply x raised to infinite, we are getting again the infinity by infinity formation. Again applying same procedure up to m minus 2. Its expression is we getting up to m minus 1, m minus 2 up to 2 into 1 upon e raised to x. So it is m factorial by e raised to x. If we are applying x raised to infinite, e raised to infinity, infinity, so we get 1 by infinity is 0. Example, prove that limit x tends to 0 log sin x sin 2x equal to 1. Solution. LHS equal to x tends to 0 log base of sin x and argument is sin 2x. So by the log rule, we are taking log sin 2x upon log sin x, we are taking log BA, then we take log A upon log B. And applying x tends to 0, so it is infinity by infinity formation. So applying L'Hopital's rule, 1 upon sin 2x d by dx of sin 2x, 1 upon sin x d by dx of sin x. So it is 1 upon sin 2x into cos 2x, 1 upon sin x into cos x, again infinity by infinity formations. Applying L'Hopital's rule, we getting 2 tan x upon tan 2x. It is 0 by 0 formations. Again differentiate in numerator and denominator, we getting 2 sec square x upon 2 sec square 2x. It is 2 into 1 and 2 into 1. Answer is 1. RHS. Formation 3 as 0 to infinity form. Working rule for this. To solve the problem of the type limit x tends to a f of x into g of x. When limit x tends to a f of x equal to 0 and limit x tends to a g of x equal to infinity, we say that limit x tends to a f of x into g of x, limit x tends to a f of x upon 1 by gx, or limit x tends to a g of x upon 1 by f of x. To new formation are the type of 0 by 0 and infinity by infinity respectively, which can be solved by L'Hopital's rule. Example, evaluate limit x tends to 0 x into log x. So L equal to limit x tends to 0 x into log x, it is 0 into infinity form. So limit x tends to 0 log x upon 1 by x, it is infinity by infinity formation. Applying L'Hopital's rule, that's why we are taking differentiation numerator in denominator. So limit x tends to 0, we get minus x, it is 0. Evaluate limit x tends to a under root a plus x upon a minus x into tan inverse under root a square minus s square. This is 0 to infinity form. We are taking a plus x into a plus x upon a minus x into a plus x. We are taking conjugate in under root tan inverse a square minus x square. So we get a plus x upon under root a square minus s square into tan inverse a square minus x square. Now 2a is common, tan inverse under root a square minus x square into upon a square minus x square. 2a limit x tends to a tan inverse under root a square minus x square under root a square minus x square. If we are assuming a square minus x square equal to y, so x tends to a, the y tends to 0. So limit y tends to 0, tan inverse y by y, it is 1. So L equal to 2a. Evaluate limit x tends to 0 log 1 plus x upon 1 minus x cot x. Limit x tends to 0 log 1 plus x upon 1 minus x into cot x, 0 into infinity form. We are taking f of x upon 1 by g of x formation. So what is the 1 by gx? It is cot x to tan x. Now it is 0 by 0 form. By L'Hopital's rule, differentiate numerator and denominator. We get cos square x upon 1 minus x square. And applying x tends to 0, we getting answer as a 2. Some example are illustrated to here to do yourself.